All right, in this explainer, we're doing something a little different. We're not just going to learn about a topic, we're going to learn how to get every single mark on it. We're going to take a real GCSE Physics exam question and absolutely nail it, part by part, using the official mark scheme to build that perfect answer. Let's get into it.
Okay, let's dive right in. So here's the challenge we're going to tackle together. It's question 01 from a GCSE higher tier physics paper, and it's all about lenses and the images they form. We're going to break it down piece by piece to see exactly what those examiners are looking for. So here's the game plan. We'll look at each of the 4 parts of the question, defining a key term, drawing an array diagram, comparing some different images, and then wrapping up with a calculation. Then at the end, we'll put it all together to see what a perfect answer looks like.
First up, part 1, the focal length. Now, this might look super simple, it's just a 1-mark question, but you know these 1-markers, they're all about precision. There's absolutely no room for waffling around here, you've got to know the exact term they're looking for. So the question is, what is this distance x called? Have a good look at the diagram. You can see these parallel rays of light coming in. They hit the convex lens and get bent or refracted, and they all meet up at one single point. So what do we call that distance from the center of the lens to that point? Right. This diagram tells us everything we need to know. The rays come in parallel, and the lens does its job, focusing them down to that single point, which you can see is labeled F for the principal focus. The distance x is just the measurement from the lens's center to that focus point.
And the one and only correct answer is focal length. The official mark scheme is crystal clear about this. To get that 1 mark, you have to write focal length, not focus point, not focal distance. It has to be focal length. See? Precision is everything.
All right, moving on. Part 2 is where we get a bit more hands-on. This is a 2-marker, and this one isn't just about what you know in your head, it's about whether you can actually draw it accurately. So here's the job. We need to complete this ray diagram. We've got the object, the lens, the principal focus points. Now we have to draw the light rays to figure out exactly where that image is going to pop up, and then draw the image itself as an arrow. Okay, so this is what you'd see on the exam paper. It's our starting point. And really, to find that image, you only need to draw 2 very specific rays of light coming from the top of the object. Where they cross over, well, that's where the magic happens. That's where our image will be. So how do we bag both of those marks? It's actually a pretty straightforward 2-step trick. First, draw a ray from the top of the object, nice and parallel to that main axis, until it hits the lens. Then it bends and goes right through the principal focus, F, on the other side. Boom, that's your first mark. For the second mark, you draw another line, again from the top of the object, but this time it goes straight through the very center of the lens. This one's easy, it doesn't bend at all. And that's your second mark in the bag. And voila, here is the finished diagram. You can see exactly where our 2 lines meet. That intersection point is crucial. You just draw a vertical arrow from the axes down to this point. This shows us the image is real because actual light rays are meeting, and it's inverted because, it's upside down. Okay, the next question switches gears a little. We just drew a real image from a convex lens, right? But now we're being asked to compare the images from both convex and concave lenses. So this really tests your all-around knowledge. We need 1 similarity and 1 difference. Now the question is asking us to compare the virtual image you get from a concave lens with the virtual image a convex lens makes when it's acting like a magnifying glass. So what's the same and what's different between those 2? Okay, so on the left, you see a typical diagram for a concave lens. It makes a virtual image. Now, the diagram on the right is the one we just drew, which shows a real image. But hang on, you've got to be careful here. The question is asking for a comparison of the typical images. The mark scheme is really looking for a comparison between the virtual image from a concave lens and the virtual image a convex lens produces when it's a magnifier. Let's think about the properties of those.
And here we go. These are all the possible answers the mark scheme will accept. For a similarity, you could have said they're both virtual, or that they're both upright, the right way up. For a difference, the big one is size. The virtual image from a convex lens is magnified, it's bigger, while the one from a concave lens is always diminished or smaller. You only had to pick 1 from each list to get the full 2 marks.
Right, let's get to the final part of this question. We're leaving the diagrams behind and getting into a calculation. This is where you'll want to have your calculator in your physics equation sheet handy. This is a big 3-marker, which means showing your work isn't just a good idea, it's absolutely essential. So, the question gives us the key info. The image height is 9.0 millimeters, and the magnification is a nice round 6.0.
Our job is to work backwards and find the height of the actual object. In this case, the letters on a coin.
So, to nail all 3 marks, you've got to lay it out perfectly in 3 steps. Step 1, write down the formula. You grab this straight from your equation sheet. Magnification equals image height over object height. That's a mark right there. Step 2, substitute the numbers in. So 6.0 equals 9.0 divided by the object height. Then show that you've rearranged it to solve. That's your second mark. And finally, you just calculate the answer.
And that gives us 1.5. But wait, don't forget the units. The image height was in millimeters, so our answer has to be in millimeters too. 1.5 millimeters. That's the third and final mark, a perfect calculation.
And there you have it. We've worked our way through the entire question. So let's do a super quick recap of what a perfect full mark answer looks like for this. So, to summarize, for the first part, the key word was focal length. For the diagram, it was all about drawing those 2 specific construction rays accurately. For the comparison, you had to know the properties of virtual images, like being upright or magnified. And for the calculation, showing all your steps, the final answer was 1.5 millimeters. Now, this quote from AQA really gets to the heart of it. It's all about standardization. What that really means is if you know exactly what the examiners are looking for, the right keywords, the steps in a calculation, that's how you turn what you know into marks on the paper. It's really about playing the game by their rules. So there you go. We've completely cracked the code on this question and the mark scheme behind it. And that leaves me with one final question for you. Now that you've seen exactly how these questions are marked, what are you going to do differently next time you're sitting in that exam hall? Something to think about. Thanks for joining me.